Welcome to Statistics, Chapter 1, Exploring Data, Section 1.2. In this section, we're going to learn how to display quantitative data with graphs, whereas the last section was about bar graphs and categorical data. Here are the objectives. Construct and interpret dot plots, stem plots, and histograms. Describe the shape of a distribution. Compare distributions and use histograms wisely. We're going to start by learning how to do dot plots. Dot plots are one of the simplest graphs to construct and interpret. Each data value is shown as a dot above its location on a number line, so you can easily tell how many there are of each. For example, if we look at below here, number of goals scored per game by the 2004 U.S. women's soccer team. So what you do is you draw a horizontal bar with your increments, of course, and then of course, like always, you label your axes. Never forget to label your axes. If you forget, they will hold that against you and count your graph as incorrect on the AP Stats exam. So let's go through. Here's a team. One team had 3, one team had 0, one team had 2, one team had 7, one team had 8, etc. And you go down here and say, all right, there was one team that had 0, so you put a little dot there. There was nobody with, with 1, there's 1, 2, 3, 4, 5, 6, 7, 8. So you're going to go put 1, 2, 3, 4, 5, 6, 7, 8 dots above 1, so I can tell you that there are 8 there. There must be, 6 that are 2, 7 that are 3, etc. on down the line. You just put a dot above the corresponding number, so not too difficult to do. The dot plot helps us when we want to examine the distribution of a quantitative variable. The purpose of a graph is to help understand the data. After you make a graph, always ask, what do I see? In any graph, look for the overall pattern and for striking departures from that pattern. Describe the overall pattern of a distribution by using what we call SOCs. This I will talk about all year. Shape, center, spread, and then talk about any possible outliers. So shape, center, spread, and talk about any outliers. Shape is it skewed one direction or the other? Is it approximately normal? Double peaked, triple peaked, symmetric? A lot of different ways you can explain it. Center, where is it centered around? Approximately what point? Later on we'll talk about whether we use the mean or the median for that kind of scenario. And then the spread is your range from lowest to highest. You can also talk about your spread in terms of your standard deviation. And your range in terms of your lowest to highest, we usually just say the one number. The spread is from 0 to 9, or it has 9. Here's an example. The table and dot plot below displays the Environmental Protection Agency's estimate of highway gas mileage in miles per gallon again. So here's our model, and here's our miles per gallon. And this is just 3 sets of data here, but it's continued. It says, describe the shape, center, and spread of the distribution. Are there any outliers? So they want us to go through and talk about SOCs. So what you would do is I would write shape, center, spread, and outliers on your piece of paper, and then go through and explain each one of them. In this graph, I would say this looks like it is, if I look at this kind of graph, skewed what we call left, centered around approximately, what would we say, centered around maybe 28, and has a spread of 14 to 33. You can also talk about that as a spread of 19 or a range of 19 with a standard deviation of, we're not sure yet, we'll learn about that in a little bit. Are there any outliers? We say there are 2 possible outliers. We have not proven outliers yet. There's an equation that you'll learn in the future here that helps us figure out if we for sure have outliers. But for right now, we'll just say with 2 possible outliers. That way we're not wrong, but we do realize that they are possibly outliers. Here's a couple more examples. A distribution is roughly symmetric when we're describing a shape. We can talk about symmetry or clear skewness. A distribution is roughly symmetric if the right and left sides of the graph are approximately mirror image of each other. I think we all remember symmetry from geometry. It's the same on both sides. So if I have a bell curve, that is symmetric because if I cut it in half, both sides are approximately the same. Could it be something like this, where it's double peaked? Yes, we still have symmetry. A distribution is skewed to the right if our data is heavy on the left side, but the data on the right side is skewing. A lot of people think this graph right here would be skewed left because our data is heavy on the left side. That's incorrect. The data is heavy on the left side, exactly. So who is skewing or messing up our data? These people here on the right. Same way with skewed left. You got skewed left graph. This would be skewed left, approximately skewed left, we don't say for sure. And then this one I would say is approximately normal or symmetric. But again, we say approximately normal. We're not going to say it is for sure normal. Comparing distributions, a lot of times they want us to compare one set of data to another. And when you do that, again, make sure you use stocks and use specific data. And you want to be specific from one person to the next. We got household size again and our place. And we're talking South Africa versus the UK. So we have two sets of graphs here that we want to compare. And of course we've got equal increments across the bottom, and we've got it labeled as household size. Make sure you label it. They will, again, mark that wrong. So this one I would say for South Africa, this is approximately skewed right with two possible outliers centered around, I don't know, if I'm going to take a guess, somewhere around here. So if I draw a line straight down, if I can possibly do that, I'd say centered around 6 or 7. Whereas the bottom one, it looks like it's more, let me clear this out, approximately normal. Now notice I'm not saying it is normal, but approximately normal. That's our shape. No possible outliers. It doesn't look like there's any outliers. Centered around, looks like centered around 4. If I drop this line down, it looks like it's centered around 4. And the spread is from, clear this back out, from maybe what, 2 to 6 would be our spread, whereas the spread here would be maybe, looks like maybe 3 to 26 would be our spread here. But you do want to compare South Africa versus UK. So I'd be more specific. I'd say the South Africa graph is skewed right, where the UK graph is approximately normal. The South Africa is centered around 6, and the UK graph is centered around approximately 4. And you'd continue on that direction, being a little bit specific as to which country. Then we get into something called stem and leaf plots, where you have a stem and a leaf, and they kind of go through and explain how to do it. I think it's easiest just to see an example. So we're going to go right on to the next one. Here's an example of how to put together stem and leaf. If I've got a series of numbers like this is 20 female AP Stats students to the question, how many pairs of shoes do you have? Well, what I'm going to do is break these numbers down, since we only have 2 digits, and break them in half. So these are all broken in half, with the number on the left-hand side being the stem. So here's our stem right here. Then the leaves are all the numbers on the right-hand side. So this 0, this 6, this 6, this 1, this 7, this 9 is, and if we continued on, would be our leaves. So that's what they did here. So this would represent 19, this would represent 13, 13, 13, 15, 26, 26, 24. And it's important to make sure that you number or write each one down. You can't say, well, I already wrote down 13. I need to know that 13 actually happened 3 times. Very similar to a graph. If I had 13 down at the bottom, dot plot, I'd have 3 dots. So it's very similar to a dot plot, but we use the actual number so we can be a little bit more specific. So we add the leaves. Then the next thing is to order the leaves. They should be in numerical order. So we can always go through and check out the median. We can see where the middle numbers are. So notice now the only difference between here and here is that they're in order. So 13, 13, 13, 15, 19, 22, 23, 23, 24, etc. Finally, don't forget a key. I don't know if this 1 bar 3 is 13 or is it 1.3. You need to make sure you let them know. Now what happens if you have multiple numbers like 210, 211, 212? Well, that's fine, but then what happens is your stem are the numbers on the left-hand side, and these numbers 0, 1, 2 become your leaves. What if you have a decimal? Same thing, you might want to round 21.23, 22.47. So what happened is you would just round, probably make this 21.2, this 22.5, and then you'd make your leaf 21, 22, 23, and then these numbers here, this 2 and this 5 would become your leaf, where the 21 and 22 would become your stems. Working with stem and leaves, we can then analyze even further. We can split them. So you got 0, 0, 1, 1, 2, 2. And all this means is I want to look further into it. And this 0 would be 0 to 4. It's basically rounding rules. And then the second 0 would be anything 5 to 9. The first one would be 10 to 14. The second one would be 14 to 19. Same thing, 20 to 24, 25 to 29, all the way down. And all that does is allows us to split that up. So I can go back to this and I can split this up and see, all right, well, we've got 3 on the lower half and 2 on the upper half. I've got 4 on the lower half, 2 on the upper half. And sometimes you can see a pattern develop when that's the case. So that would be a split stem and leaf, a split stem and leaf where I've split the numbers 0, 0, 1, 1, and then I just go according to rounding rules as to which line they belong on. There's also something called a back-to-back stem and leaf. This I might use to compare one store to another or one gender to another, as they did in this case. So here's an example. 0, 4, I look at all the males, and 0, 4, 05, 05, 05, 06, 07, 10, 10, 10, 10, and then I can look over here on the females and go back and compare the two, and I can say, all right, well, females had a higher 57, 50, 50, 51. They had a higher count than the males. Males were on the lower end, females were on the upper end. I can also go back, and if you tilt your head to the right, you can look at the males and go, that looks like it's approximately skewed right. If you look to your left, this is a little bit different because you're going from 0 to high, but this one looks like it's approximately symmetric. But you can kind of turn your head and go ahead and do socks, even off of a stem and leaf, shape, center, spread, and if there's any possible outliers. It's just another way to do a graph. Then we get into histograms. Histograms people have seen before. Most people know what a histogram is. All it is taking our data and putting it into a graph. Now, a histogram and a bar graph are different. People think they're the same. Bar graph works with qualitative or categorical data. Histogram works with quantitative data, and it's important that you understand the difference between those two. In a histogram, we talk about frequency or relative frequency. Again, remember relative frequency, that word relative means we converted it to a percent and put that along the y-axis. But you do want to make sure when we go to make a histogram, you have your y-axis and your x-axis. You've got equal increments along the x-axis, equal increments along the y-axis. They don't have to be the same, but they should be equal. You absolutely have to label each axis, and then you can go ahead and graph. There are from 0 to 5, the percent of residents from each state who were born outside the U.S. 0 to 5, there are 20 states. So I'd go 0 to 5, there are 20. So I'd go up here and mark my little line across, bring it down. Now this is not going to be the cleanest because it's done via tablet here, but you'll get the idea. Then 5 to 10, there's 13. So I go here and mark 13. That's 5 to 10. Then you got 10 to 15, there are 9, so I'd make 10 to 15, there are 9. And then 15 to 20, there are 5, so I go down here and 5. And either way, when you're finished with this, you get your total, and I can already tell you this looks like it's, without graphing the last two, but we know it continues to decrease, that this is skewed to the right, to give you an idea. So then we can use a histogram. Again, these bars do touch because you go 0 to 5, and then you pick up from 5 to 10, and then you pick up from 10 to 15. There's no reason to leave space because they're not categorical, they're actual numbers. Even if we had to drop a spot and then go across because there was nothing here, that's fine. We still have to leave the space for it. But that would be a histogram. Most of us see histograms in the newspapers or in other classes that we've taken. Just make sure that you use histograms wisely. A couple of notes here are cautions. Don't confuse histograms with bar graphs. We talked about that. Don't use counts in a frequency table or percents in a relative frequency table as data. Realize that they're just numbers and quantity. Use percents instead of counts on the vertical axis when comparing distributions with different numbers of observations. That's a perfect example. When different numbers of observations, then you want to stick with percents. And just because a graph looks nice, it's not necessarily a meaningful display of data. Just always keep that in mind. We have different options as we get through the year, and you want to be able to use your best option. And then even then, you graph it. Remember, it's not the means to the exact data. All right. Summary. In this section, we learned a couple of things. One, the use of a dot plot, a stem plot, and a histogram and what their differences were. We learned about talking about overall patterns and making sure we emphasize SOCs. That is something I'll be emphasizing all year: shape, center, spread, and describing any outliers. Talk about symmetric versus skewed, skewed right versus skewed left, and any modes. If we have multi-modes like 2 or 3 or major peaks, then we talk about those. When comparing distributions of 2 or more companies or 2 or more stores or 2 or more businesses, whatever it might be, you always want to talk about shape, center, and spread, so SOCs, but be specific from one to the next. And histograms are for quantitative data, just something to remember. In the next section, section 1.3, we will learn about mean and standard deviation, median and interquartile range, 5-number summary and box plots, and identifying outliers. Here we start to get even more specific. So look forward to that as we continue on. I hope that helps with section 1.2.